Hello everyone. In this video, we'll be discussing about the pressure exerted by liquids and gases. We all know that there are many instances in our day-to-day life which involve pressure exerted by liquids and gases. Some of them are like a football, a submarine, or simply our gas balloons. In this video, we'll try to understand about the pressure exerted by liquids and gases separately. We'll also see some experiments which will be demonstrating the effect of pressure exerted by both liquids and gases. Coming to pressure in gases, let us see some real life examples. What are we observing in this picture? A person is pumping the cycle tire, right? What do you think he is doing to the tire? Similarly, the other person is blowing a bubble gum, right? What do you think he is doing by blowing the bubble gum? Some common examples where we experience glass pressure also include a football and our pressure cooker. Let us understand these examples by exploring the concept of pressure in gases. As mentioned earlier, pressure is the force acting per unit area of a medium. In case of liquids, the pressure is due to the height of the liquid above a section. However, in case of gases, the molecules are freely moving. During this motion, they collide with each other as well as with the walls as shown in the picture. To understand how the pressure in gases will arise, let us consider a gas balloon. If we consider a unit surface area of this balloon as shown here, the force caused on the walls of the surface due to the collisions of gas molecules is the pressure exerted by the gases. So, higher the number of molecules, higher the collisions, and higher the collisions, higher the force. So, this is what happens when we inflate a tire or blow a bubble gum. We are adding more number of molecules to increase the pressure in tires or a bubble gum. Okay, coming to pressure exerted by liquids. Here in the first picture, you are seeing that this man is applying force to stop the jet coming through the hole, right? Why do you think he needs to apply force to stop the jet? Now, coming to the second picture. Here you are observing a submarine, right? Why do you think the submarine has to be so robust or strengthy as seen here? These questions can be answered by understanding the concept of pressure exerted by liquids. Pressure is the force that is acting over a unit area of a medium. In case of liquids, the pressure is exerted due to the liquid that is above a particular section. If you consider a tank of unit area as shown here, the section shown in green color experiences the force due to the liquid that is present above it. This force is the pressure exerted by the liquid at that section. Okay, now let us consider some features associated with pressure exerted by liquids. The first feature is that the liquid exerts pressure on the solids that are in contact with it. We all know liquid needs a solid container to hold it. If we consider a tank containing liquid as shown here, now in this tank we already know that all the locations in the tank experience pressure due to the liquid above it. In the same way, the solid base at the bottom also experiences the pressure P due to the liquid above it as shown here. Similarly, the solid walls at any location also experience some pressure P1 as shown here. To understand this, let us do a small experiment. In this experiment, we demonstrate the pressure exerted by liquid on solid walls of a container. The materials required are a normal water bottle with a hole at a location, an outlet pipe, a plastic tag and a balloon. The outlet pipe is attached to the hole of the bottle and a balloon is attached to this pipe. The final assembly looks like this. Initially, the balloon attached to the bottle outlet will be flat as shown here. Now, let us fill the bottle with water. As we do so, the pressure at the hole location or the balloon location increases. As this pressure increases, the force on the balloon walls also increases. Hence, balloon gradually bulges out as shown here. This simple experiment thus demonstrates the pressure exerted by liquids on the solid walls of a container. The second feature that we will see is that the pressure depends on the height of the liquid column above it. It is obvious from our understanding that the pressure exerted by liquids at a location is due to the liquid above it. So, as the depth of a location increases, the pressure at the location increases simultaneously as shown here. This effect can be understood through an experiment by considering a bottle with holes at different heights. So, the materials required for this experiment are a bottle with holes at two different locations and outlet pipe. The final assembly looks like this. Initially, we fill the bottle till the top by closing the holes. Now, as we open the cap, there will be a water jet passing through both the holes as shown here. As the liquid discharges, it can be seen that the jet through the top hole falls at a location nearer to the bottle compared to the jet from the bottom hole. Once the liquid crosses the top hole, the jet from the bottom hole behaves in the same way. That is, the position where the jet falls on the ground decreases as the height of the liquid above the hole reduces. This happens due to the reduction in pressure. This simple experiment thus illustrates that pressure at a location depends on the height of the column above that location. As we understood that the liquids exerts pressure on the solids and this pressure magnitude increases with height, now we can think of a submarine. We know that submarine travels at very deep locations inside a sea. Hence, from our knowledge on pressure exerted by liquids, it is obvious that submarine must sustain very high pressures exerted on it by the liquid in the sea. This is the reason why a submarine must be so strengthy. Now, the pressure exerted by the atmospheric gases around us is called the atmospheric pressure. Now that we have understood the pressure exerted by liquids and gases, let us see some simple experiments involving the effect of both pressure exerted by liquids and gases. Till now, we have performed some experiments where we have used a water bottle with some holes. Using this, we have demonstrated some features of pressure in liquids. But did you think what is happening at the top of the whole bottle? Can we have a jet through the whole of the bottle independent of whether the bottle is open or closed? Let us understand this by doing a simple experiment. The materials required for this experiment are a water bottle with a hole and an outlet pipe. The final assembly looks like this. Now, initially when the bottle is filled with the water and closed with the cap, there is no flow through the outlet, right? Now, let us see what happens when we open the cap. So now you can observe a jet coming through the outlet, right? Now, if we close the bottle again, let us see what happens. So, when we close the bottle, the flow stops again. So, we observe a flow only when the bottle is open, right? Let us understand the reason behind this happening. Now, consider the open water bottle. The external pressure at the outlet is always the atmospheric pressure, while the internal pressure varies depending on the condition. When the bottle is open, the internal pressure at the outlet is the sum of the atmospheric pressure and the liquid pressure. So, clearly the internal pressure is considerably higher than the external pressure. Hence, we see a jet in case of an open water bottle. Now, come to the case of closed water bottle. Here also, the external pressure at the outlet is atmospheric pressure. But the internal pressure now is reduced as the bottle is closed. It is the sum of the liquid pressure and the gas pressure due to the gas trapped above the liquid. So in this case, the external pressure is higher than the internal pressure. Hence, we will not see any jet. Now, let us see another simple experiment emphasizing the effect of gas pressure. This experiment is known as the water fountain experiment. The materials required for this experiment are a water bottle with holes at a height nearer to the top as shown, and also a cap with a hole a balloon and few plastic straws. The final assembly looks like this, with the straws immersed into the bottle through the holes. Initially, even though the bottle is open, there won't be any flow as the holes are not at a deeper location like earlier cases. Now, we fix an inflated balloon to the bottle by using the cap with a hole as shown here. Let us see what happens. So, we can see that there are jets coming out of all the outlets. Let us try to understand what is happening here. Here, the gas pressure due to the gas in the balloon at the top increases the internal pressure at the outlets and makes it higher than the external atmospheric pressure. Hence, we see the jets coming out of the outlets seeming like a fountain. So, what did we learn? We understood the pressure exerted by liquids and gases and some of their features. We explored some daily life events associated with this topic. We also observed some interesting experiments involving the pressure exerted by liquids and gases. Thank you.